Right. sp hybridization. What is sp hybridization? Intermixing of one s orbital and one p orbital to form two sp hybridized orbitals. This is called as sp hybridization. Bond angle data, examples data is important, and the geometry also. Okay. What is bond angle in case of sp hybridization? Online students, what is bond angle? Bond angle 180. Geometry, geometry. Linear geometry. Geometry is linear. Examples, examples. C2H2, CO2, BeCl2. These are the examples. Okay. Percentage of S character and P character. What is percentage of S character? Percentage of S character, 50%. Percentage of P character, 60%. Next, sp2 hybridization. One s orbital and two p orbitals mixed together to form three sp2 hybridized orbitals. Three sp2 hybridized orbitals. Bond angle. Bond angle in case of sp2. How much bond angle? sp2 120 degrees. 120 degrees. And geometry. Geometry. Trigonal planar geometry. Trigonal planar geometry. Examples category. Examples. BCl3, BCl3, BF3. Right. Percentage of S character. Percentage of S character. How much percentage of S character? sp2. 33.33%. Percentage of P character. 66.66 approximate. Okay. sp3 hybridization. One s orbital plus three p orbitals mixed together to form four sp3 hybridized orbitals. Online students, are you getting? Hello. Bond angle data. sp3 hybridization. 109 degrees and 28 minutes. 109 degrees, 28 minutes. Geometry. Geometry. Tetrahedral. Tetrahedral. In most of the cases. Tetrahedral. If sp3 hybridization is present, then geometry is tetrahedral. Examples category. Examples. CH4, NH4 positive. Okay, CCl4. Percentage of S character. Percentage of S character. 25%. Percentage of P character. 75%. sp3d hybridization. sp3d. One s orbital plus three p orbitals plus one d orbital to give how many hybridized orbitals? How many? 5 sp3d hybridized orbitals. Bond angle. Bond angle. 120 and 90 degrees. Geometry. Geometry. Trigonal. Trigonal. Bipyramidal geometry. Trigonal. Bipyramidal. Trigonal. Bipyramidal. Examples PCl5. S3Cl5. Percentages. How can we find percentages? How can we find percentages? In that, what is the percentage of S character? Percentage of S character. Very simple. If you don't know, apply simple mathematics. Total, how many orbitals are there? 1 plus 3 plus 1. Total 5. 1 s orbital, 3 p orbitals, and 1 d orbital. 5. So 1 by 5. You can simplify, convert it into decimals. Okay, right. In case of p orbitals, 3 by 5. S character and D character is same here. Correct on, no? S character and D character. This idea is very, very important. Basic idea, basic information. Okay. Okay. Next. Are you ready? Please respond, all of you. Hello. Well, let us start numeric. Numerical synthesis questions related to need, finding hybridization. We completed basic information. Finding hybridization. Next part. Finding. Finding hybridization. Valence dot method. Valence dot method. CH4. Very simple method. No need to use any formula. Carbon belongs to which group? Carbon. Online students. Carbon belongs to which group? Fourth group. So keep four dots. Fourth group. Four dots we have to keep. One, two, three, four. What are surrounding atoms? Hydrogen. Right surrounding atoms H. These are surrounding atoms. Okay. Hmm. Once look at this. Remember, hybridization should start with always S. After that, P orbital. P orbital again classified into three. After that, D. 5 d orbitals, 3 p orbitals. Px, py, pz, in atomic structure. First, alert s orbital. Yes, here. Yes. Next, p. How many p orbitals we have? So, p and px, py, pz. That's why we wrote p. So, total one s, one s orbital and 3 p orbitals. So, sp3 hybridization. Valence dot method. Clear, everyone? No, right. Number of lone pairs. Number of lone pairs. Zero. Is there any lone pair remain here? Number of bond pairs. How many bond pairs are present here? Tell me. How many bond pairs are present? Online students. Misbah, how many bond pairs are present here? Bond pairs. Four bond pairs. So number of bond pairs, lone pairs also very, very important. Okay. Right. Remember, all of you, first start with s orbital, allot s orbital for the surrounding. After that, p orbitals, 3p. If p completed, then go for d, d orbital. Okay. See this example, PCl5. Second example, PCl5. Phosphorus belongs to which group? Phosphorus belongs to which group? Nitrogen, phosphorus, arsenic, antimony, bismuth, fifth group. So first select central atom. Phosphorus is the central atom. Phosphorus belongs to fifth year group. So keep five dots. One, two, three, four, five dots. And how many surrounding atoms are there? Five surrounding atoms. So chlorine, chlorine, chlorine. Right. Five surrounding atoms are allotted. Right. For each surrounding atom, allot orbitals. First, we will give s orbital. After completion of s orbital, p, p, p. Three p orbitals are completed. So next, d. Right. So how many s orbitals? One. And p orbitals are d orbitals. So sp3d hybridization. Clear? Number of bond pairs, 5. Number of lone pairs, 0. Can you do few examples? Do it. Tell me. Ritika, what is the answer? Pranavi, for NH3, what is hybridization value? Pranavi, Pranavi, answer for NH3. Ragnika, what is the answer for NH3? Ragnika, Shravya, Misbah, Akshara, what is the answer for NH3? Good. Any lone pair? Akshara, lone pair, bond pair, one lone pair. Nitrogen belongs to which group? Yes. Nitrogen belongs to fifth group. So five dots. One, two, three, four, five dots. Allot surrounding atoms. Hydrogen, hydrogen, hydrogen. And now write orbitals. S orbital, p orbital, p orbital. If any lone pair is remained, what we have to do? What we have to do? Put one lone pair in one circle or two electrons in one circle. If any lone pair remained, if electrons remained, take two electrons, put in one circle. And allot orbital for that circle also. Yes, P, P for this circle also one orbital. So sp3. If any electrons remained, what we have to do? Take two electrons, put in circle. Or one lone pair, put in one circle. Now coming to XZF. What is the answer of XZF? Xenon belongs to which group? 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. Fluorine, fluorine. If any electron remained, what we have to do? Circle, circle, circle. Okay. Allot orbitals. Yes. P for this circle also. P for this circle also. P. Next also P. No. Already three P orbitals are over. Next D. So sp3d. sp3d hybridization. Okay. Number of lone pairs, three lone pairs. Number of bond pairs, two bond pairs. Here number of lone pairs, lone pair one, bond pair. Here lone pairs, three. Bond pair, two bond pairs. In H2O, oxygen belongs to which group? 6A group. So six dots. One, two, three, four, five, six. Six dots. Hydrogen, hydrogen. If any electron remained, then what we have to do? Keep two electrons in one circle. Two electrons in one circle. Yes, P, P, P. sp3 hybridization with two bond pairs and two lone pairs. Bond pairs are two, lone pairs also two. Ragnika, are you getting? Ragnika, Ragnika, are you there? For cations and anions. For cations and anions. NO3 negative, SO3 minus, NH4 positive. How to do? in case of negative ions and positive ions. How to do? If negative charge is present, how much negative charge is present? We add that many electrons. If one negative charge is present, we add one electron. If two negative charges are present, we add two electrons. Let us see. Nitrogen belongs to which group? 50A group. So five valence electrons at the same time, one extra because one unit negative charge is present. So six electrons. One, two, three, four, five, one extra electron because of charge, right? And one more important point, if oxygen is present, allot two dots for single oxygen, two dots for single electron, two dots for single. In case of other atoms, one electron, one surrounding atom. In case of oxygen, allot two electrons for one oxygen. In the last case, what we did for PCl5 case, we allotted one electron, one chlorine, one electron, one chlorine, one electron, one chlorine, like this only, no? But here, two electrons, one oxygen atom, because oxygen valence is two, means bonding capacity is two. That's why we allot two electrons for oxygen. See the difference, only for oxygen atom. Got it? Only for oxygen. What is hybridization here? What is hybridization? sp2 hybridization. sp2. Here, SO3 minus 2. Sulfur belongs to which group? Yeah. 1, 2, 3, 4, 5, 6. Six electrons over. Next, more two electrons. Why? Because charge is minus 2. Minus 2. In case of oxygen, what we will do? Allot two electrons for one oxygen. Allot two electrons for one oxygen. If any lone pair is remained, then what we will do? Circle. Circle. So yes, P for this also 1p orbital. So hybridization is sp3 hybridization. Right. In case of positive charge, what we will do? We will subtract electrons. Nitrogen belongs to 50A group. Instead of writing 5 electrons, what we will do? We write 4 electrons only. 1, 2, 3, 4. Don't write 5 because positive charge is present, we have to subtract. How many surrounding atoms are there? 4 surrounding atoms. So hybridization is PPP. sp3 hybridization. In case of charges, in case of oxygen, we'll do like this. Any doubt? Online students, did you get this? All of you. Hmm. Let us do hybridization in organic molecules. In need two times question given different related to organ, right? Hybridization in organic compound. See, if carbon is surrounded by all single bonds, then its hybridization is sp3. If carbon surrounded by one double bond, then its hybridization is sp3. If carbon surrounded by triple bond, then its hybridization is sp3. If carbon is surrounded by two double bonds, this side, that side, then also hybridization is sp only, not sp2, sp only. These two are sps. Okay. Based on this, we will do some questions related to organic molecules. Here, see, in hybridization, you won't believe they use nomenclature logic. Let us see how. I will give the previous question. They link it to nomenclature. How they linked hybridization and nomenclature? Let us. Okay. PYQ. What is the hybridization of C1 and C2 carbon? That is the question. What is the hybridization of C1 and C2 carbon? First of all, let us draw the structure. What is the functional group present in this? We completed nomenclature recently. Ragnika, yes or no? Ragnika, we completed or not? What is this? Yes or no? This is yes or only. Investors, how we will give the numbering from this carbon? Once revise this. So recently I completed. One, two. Okay. Right. So first carbon, second carbon, hybridization we have to find. Carbon is having double bond, na? So hybridization of this carbon is sp2. Here, single bonds only. Hybridization is sp3. No doubt. Are you getting online, students? Is everything okay for you? Pragmatic only not responding. Everyone is responding. Pragmatic, are you there? Hello. Hello, Pragmatic. Right. Clear how questions will come. This is also PYQ on previous year question. With this, how many sp2 and sp hybridized carbon atoms are present? 1 in 3 ion. 1 in 3 ion. How many sp and sp2 hybridized carbons are present? Sp and sp2. What is the answer? First pent, right? 5 carbons. Well, first position, double bond, 1 in. Third position, triple bond. Balance the atoms, right? This is double bonded carbon, sp2, sp, sp, is sp3. Got it online, students? Now see, sometimes we will get different question. Hybridized carbon is different. How many? No, wait. I'll give the question. Mostly you will do the wrong. Then I'll explain. If I explain directly, you may not remember. Okay. Note down next question. Important. How many sp3 hybridized orbitals are present in propene? How many sp3 hybridized orbitals are present in propene? How many sp3 hybridized orbitals are present in propene? Online students? 1. What is the answer? How many sp3 hybridized orbitals are present in propene? Propene structure is, this is structure of propane. Okay. This is sp2. This is also sp2. This is, what is the question? How many sp3 hybridized orbitals? How many sp3 hybridized carbons? That is not question. That is different. If I ask you like this, how many sp3 hybridized carbons means your answer will be 1. But the question is sp3 hybridized orbitals. Now look at going to the definition. Let us go to sp3 hybridization. What is definition of sp3 hybridization? 1s orbital plus 3p orbitals undergo hybridization to produce how many hybridized orbitals? 1s orbital plus 3 orbital to give how many? 4 sp3. So answer is 4. 4 is the answer. Got it? How many sp3 hybridized orbitals? I didn't ask about how many sp3 hybridized carbons. I asked hybridized orbitals. So we'll go to the definition. This is sp3 hybridization in this carbon. So 1s orbital, 3p orbitals to give 4 sp3 hybridized orbitals. Now can you say how many sp2 hybridized orbitals for the same question? How many sp2 hybridized orbitals are present? Online students. How many sp2 hybridized orbitals are present? 6. How 6? sp2 means according to the definition 1s orbital and 2p orbitals to produce 3 sp2 hybridized. Here also 3 sp2 hybridized, 3 plus 3 is 6. 6 sp2 hybridized orbitals, which is the correct answer. Okay, right. Hybridization concept is okay. Shortcut method, valence dot method, taking valence electrons and finding hybridization. Uh, Next, VBT, valence bond theory. Counting sigma and pi bonds concept also very, very important, and questions are coming. Questions are coming on this. In which of the following 4 sigma bonds are present, 1 pi bond is like different types of questions. Valence, VBT. Let us discuss few postulates of valence bond theory. According to valence bond theory, orbital overlapping is mandatory for chemical bond formation. Orbital overlapping is mandatory or important. Orbital overlapping is mandatory for chemical bond formation. Orbital overlapping is mandatory, important. Overlapping of orbital is important. If extent of overlapping is more, then strength of bond is more. See, this is one orbital, this is one orbital. Here extent of overlapping is more, strength of bond is more. Now, extent of overlapping is less. If extent of overlapping is more, strength is more. If extent of overlapping is less, strength is less. Finally, overlapping is mandatory. Clear? Right. See, the order of overlapping of different orbitals. The order of overlapping. The order of overlapping is 1s between 1s and 1s. Extent of overlapping is more. Next to p orbital, any p orbital. 2p, 2p, 3p, 3p, any p. But 1s only, I am particularly mentioning. 1s between two 1s orbitals, extent of overlapping is more when compared with the other combinations. Okay, pp, then ft, Then SS actually, SS means other than 1s1s. Got it? Other than 1s1s. Here 1s, alright, so here only wrote S, here also wrote S means here other than 1s1s. Other than, very, very important, other than 1s1s. Got it? For example, look at this. Can I write like this? 2p, 2p greater than 2p, 2s greater than 2s, 2s. Is it correct or wrong? Correct only. Here, other S orbitals will come other than 1s1s. This is correct. But when 1s1s is given, you have to keep in first. We have next, right? One note. Single bond contains single bond contains only one sigma bond. Only one sigma bond. Sigma bond is formed due to how sigma bond is formed? Due to head-on overlapping or linear overlapping. Okay. Sigma bonds only decide the geometry of the molecule. First, which bond formation takes place in the molecule? Sigma bond formation only. Okay, I'll give that information also. Single bond contains only one sigma bond. Double bond contains how many? One sigma bond plus one pi bond. One. Triple bond contains one, one sigma, two pi. All right. And some additional information of sigma and pi bonds. Sigma bond, pi bond. Formed due to formed due to linear or head-on overlap. Linear or head-on overlap. Formed due to formed due to sidewise overlapping. Sidewise overlap. First sigma bond formation takes place. First sigma bond formation takes in the molecule. After that only pi bond formation takes place. Sigma bond can exist independently. Yes or no? Yes. Sigma bond can exist independently. First sigma bond formation takes place, so sigma bond can exist independently. But pi bond is formed after formation of sigma bond only. Pi bond is formed after after formation of sigma bond. After formation of sigma bond. So pi bond do not exist independently. It exists always along with the sigma bond. Which bond decide the geometry of the molecule? Sigma bond. Sigma bond only decide the geometry of the molecule. Decides decides geometry. Do not decide the geometry. Do not decide the geometry. Okay. Previously questions asked and number of sigma and pi bonds. Let us cover important examples. Here nomenclature idea is very, very important. Let us start the questions. Previous model questions. Calculating number of sigma and pi bonds. Calculating number of sigma and the pi bonds. Ethene, ethene, acetylene, acetylene, CaC2. This is important example. Calcium carbide, CaC2. Third one, CaC2. Fourth one, benzene, benzene. Can you say ethene? Ethene is having how many sigma and pi bonds? Ethene is having one sigma and one pi bond. Online students, online students. Ethene structure. Ethene are also called as ethylene. Ethene or ethylene. Ethene or ethylene. CH2 double bond, CH2. 1 sigma and 5 pi bonds. Let us. Pi bond. See, this is double bond. No? In double bond, one is sigma, one is pi. And I am representing sigma bonds with another color. Pink color represents sigma bond. Single bond is sigma bond. 1, 2, 3, 4, 5. 5. So, one pi bond and 5 sigma bond. Next, acetylene. Acetylene. Acetylene structure C2. That's 2 formula. Structure is how many sigma bonds are there? And how many? 2 pi bonds. In triple bond, 2 bonds are pi bonds. Sigma bond, sigma bond, sigma bond. 3 sigma bonds and 2 pi bonds. What is the ratio of sigma and pi bonds? Here, sigma bond to pi bond ratio. Ratio also will come. Ratio 3 is to 2. 3 sigma bonds. Ratio of sigma and pi bonds. And CaC2 example. In CaC2, important example, this is calcium carbide. CaC2. CaC2 can be written like this. Remember all of it, right? Calcium belongs to which group? Calcium belongs to which group? Beryllium, magnesium, calcium. Second group. Start all of you group learning group list like organic. Okay, daily sometime. Clear? Calcium belongs to second. So plus two. It is having plus two. So carbon is having negative negative. This is ionic compound CaC2. Clear? And bond present between calcium and carbon is ionic only. Don't consider this. Don't consider dot dot dot. That is not a covalent bond. We consider only covalent bonds for the counting. This dot 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 cannot be considered. So count this only. Consider this only. This is triple bond or not? In triple bond, one is sigma and what? 2 are pi bond. So in CaC2, one sigma bond and 2 pi bonds are present. Okay, important example. CaC2, calcium carbide. And benzene structure. Tell me anybody, benzene. In benzene, how many sigma and how many pi bonds are present? Twelve sigma and pi. P6H6 is the form of P6H6. Right, 6 hydrogen H. Okay. Sigma bar. I'm writing sigma bar. In double bond, one is sigma. In double bond, one is sigma. In double bond, one is sigma. This is single bond sigma. This is single bond sigma. This is single bond sigma. And I'm writing pi bond with different color. This is double bond pi. Double bond pi. Because in double bond, one is sigma, one is pi. In double bond, one is sigma, one is pi. In double bond, one is sigma, one is pi. So what is the ratio? Sigma bonds are what? Pi bonds are. What is the ratio? Ratio 4 is to 1. 4 is to 1 only. No? 12 is to 3 will come. Simplify this. So counting sigma and pi bonds with some organic compounds and their names. Next, valence shell electron pair repulsion theory, the most important. You can see PY quiz. Several times question came. Memory based only memory based. Okay, what you have to do the combinations. If two bond pairs, one lone pair is present, what is the geometry? Three bond pairs, one lone pair is present, what is the geometry of sheet? Okay. The most important, you can manage through PDF directly. If you manage, then I'll go to bond MOT. That is memory based only directly. Okay. I'll give homework and I'll make you to read it. Clear? All of you. Okay for you, or I have to explain? You tell me. Direct table only you have to by heart. Uh, I'll send the notes. One day I'll make you to sit. Just half an hour only it takes. Okay, examples category. Two bond pairs, one lone pair. What is the geometry? Can you manage? All of you. Then I'll go to MOT, molecular orbital theory. All of you. You tell me, online students. Santoshni, what about you? Misbah, can you manage? Hmm. Because memory based only, no, that's why we should waste the time. Molecular orbital theory. Molecular orbital theory. MOT, generally abbreviated as MOT. Molecular orbital theory. By using MOT, we can predict the bond order. We can predict the paramagnetic property or diamagnetic property. Very, very important. Means whether one molecule is paramagnetic or diamagnetic. Okay, and we can predict even existence of the molecule also. Whether one molecule will exist or not. These are major concepts. Bond order, paramagnetic property, diamagnetic property, existence of the molecule. First of all, coming to the definition, introduction of molecular orbital. What is a molecular orbital? Molecular orbital is formed by the linear combination of atomic orbitals. See the definition of MO. MO stands for molecular orbital. MO stands for molecular orbital. Molecular orbital is formed by linear combination of atomic orbitals. This is called LCAO, linear combination of atomic orbital. LCAO method. L stands for linear, C stands for combination, A stands for atomic, O stands for orbit. Linear combination of atomic orbital. Look at this, all of you. This is one atom and this is also one atom. This is atomic orbital. Atomic orbital. Let us consider this is center of the atom. This is center of the atom. What is center of the atom generally? Center of the atom means nucleus. Hmm. This is molecular orbital. Molecular orbital. Look at this, all of you. Atomic orbitals are monocentric. Monocentric means they are having only one center. What about molecular orbital? Molecular orbital is dicentric or polycentric. Atomic orbital is monocentric, one center is present. Molecular orbital is dicentric or bicentric or polycentric. Polycentric. Write that points only. Here, electron is influenced by one nucleus. Here, electron is influenced by Electron is influenced by how many nucleus? Two nucleus. Got it? This is one atom, now one nucleus is present. So electron is influenced by one nucleus. Here electron is influenced by two nucleus. Write that point. Important point. Atomic orbital is atomic orbital is monocentric and influenced by electron. And electron is influenced by one nucleus. Molecular orbital is dicentric or polycentric. Dicentric or polycentric. Influenced by electron is influenced by two nucleus. And the electron is influenced by two nucleus. A nuclei example. Okay, right. What is a molecular orbital? Molecular orbital is formed by the linear combination of atomic orbital. Okay. Molecular orbital. MO stands for what? Molecular orbital. Molecular orbital is of two types. Bonding molecular orbital BMO, anti-bonding molecular orbital ABM. Bonding molecular orbital and anti-bonding molecular orbital. See, when atomic orbitals combined together, they form two types of orbitals. So this is one atomic orbital, this is one atomic orbital. When they combine together to form two types of orbitals. One is bonding molecular orbital, one is anti-bonding molecular orbital. These are atomic orbitals. They are combining to form bonding molecular orbital and anti-bonding. Two types of molecular orbitals are formed. What are the? Let us BMO, bonding molecular orbital. See, this is wave diagram present in one orbital. Wave diagram in another orbital. In phase overlapping. Positive, positive. See, imagine lift this and place on this. Positive, positive is matching or not? Negative, negative is matching or not? This is in phase overlapping or simply constructive overlap. It is formed due to, sometimes theory questions will come, formed due to constructive overlap. Formed due to constructive overlapping. Constructive overlapping. Bonding molecular orbital is formed due to constructive overlapping. Constructive means positive, positive will match together. Constructive. See, plus 2. What is the value? Plus 4. Correct only, na? Value is increasing or not? See, height of the wave increasing. Because plus both are added. Constructive overlapping. So for NEET students, for NEET, just basic idea. What is a molecular orbital? Molecular orbital is formed due to combination of atomic orbitals. Types of molecular orbitals, two types, bonding molecular and anti-bond. How bonding molecular orbital is formed due to constructive overlapping of the atomic orbitals. Guess how anti-bonding molecular orbital is formed due to destructive overlapping. Formed due to destructive overlapping of atomic orbitals. Destructive overlapping of atomic orbitals. Positive, negative. Yes, here, negative, positive. Positive is joining with negative. Plus 2 minus 2 means 0. destructive overlapping. So IBMO is formed due to destructive overlap. Clear? Online students, are you getting? Online students. Let us take one diagram which represents bonding, anti-bonding, and atomic orbital. Diagrammatic representation. AO stands for AO stands for atom, atomic orbital. Bonding molecular orbital. ABMO, anti-bonding molecular orbital. Here, very important point. Bonding molecular orbital is represented by sigma. Tell me, sigma or pi. Bonding molecular orbitals are represented by sigma or pi. Anti-bonding molecular orbitals are represented by sigma star or pi star. Sigma star or pi star. Let us consider this is energy barrier. Energy barrier of atomic orbital. Atomic orbital. Whose energy is more? By seeing this diagram, tell me. Whose energy is more? Yes, very good. Energy order. Energy order. Which is having higher energy? ABMO, anti-bonding molecular orbitals are having more energy than atomic orbitals. Atomic orbitals are having more energy than bonding molecular orbital. See the order: lower energy, moderate energy, and higher energy. Okay. Coming to the questions, need model question. Several times this question came. Let us complete that first. Then we'll go with the configuration, molecular orbital theory configuration. Okay. Shortcut method. First, I'll explain shortcut method. How to find a bond order. VO stands for what? Bond order. What is definition of bond order? Bond order definition. Bond order definition. Number of bonds between two atoms. Number of bonds between two atoms is called as bond order. In between two hydrogens, how many bonds are present? One. So bond order is one. Here bond order is two. Bond order is maximum bond order is, guess what is the maximum bond order? Maximum BO. What is maximum bond order? Three only. More than three, not possible. Okay, maximum bond order is three only. Number of bonds between two atoms is called as bond order. You know shortcut method, 14 electron table, everyone. 14 electron table. Shortcut method for the bond order. 14 electron table. Hmm. Let us start with the 14 electrons. See, number of electrons and the bond order. Start with 14 electrons. 14 electrons. For 14 electrons, bond order will be 3. See, if you increase number of electrons, or decrease number of electrons, you should change the bond order by zero point 0.5 only. Reduce bond order by zero point 0.5. I am increasing number of electrons 15. For 15 electrons, bond order is 2.5. For 16 electrons, bond order is 2. For 17 electrons, bond order is 1.5. For 18 electrons, 1. For 13 electrons, if you decrease number of electrons, then also you have to reduce 0 0.5 only, 2.5. For 12, 2. For 11, 1 point. For 10, 1. So based on this table, we can find the bond order easily without using the formula MOT, molecular orbital configuration. Let us start. Okay. First example, O2. O2. How many electrons are present in O2? Oxygen atomic number is 8. 16. 16 electrons. Bond order is 2. Bond order is equal to 2. CO, carbon monoxide. Carbon contains how many electrons? Carbon atomic number. Atomic number of carbon 6. Oxygen atomic number 8. 14. 14 means bond order is 3. If positive sign is, if cation or anion, in case of cation or anion, N2 positive. N2 positive. First of all, write number of electrons in N2. 7 plus 7, how much? 14. What is the sign? Positive or negative? When positive sign is present, reduce 1. Subtract 1. 13. If positive sign is present, subtract 13 electrons. 13 electrons means 2.5. Bond order is equal to. Okay. O2 negative. Tell me, all of you, O2 negative, O2 positive, all of you. Say the bond order directly. O2 negative bond order, online students. O2 negative contains how many electrons? Online students. O2 negative contains how many electrons? Online students. 15 electrons. O2 negative. O2 negative. Oxygen atomic number is 8. 8 plus 8. Negative charge. Negative charge is present, then we have to add 1. When positive is present, we will subtract. When negative is present, we add. 8 plus 8, 16. 16 plus 1, 17. 17 means 1.5. Bond order is 1.5. O2 positive. Positive sign is there. Now subtract. 8 plus 8 minus 1. 16 minus 1, 15. 2.5 is the bond. Got it, all of you? What are the applications of bond order? If we know bond order, what parameters we can compare? If you know bond order, you can predict bond length between them. You can predict bond strength between them. If bond order is more, bond strength is more. See, 3 bonds, bond order is more, bond strength is more. If 1 bond only there, bond order is less, strength is less. Bond order, bond length, bond strength. Let us see. Okay. Applications of bond order means if you know bond order, what parameters you can compare? Applications of bond order. Bond order is inversely proportional to bond length. If bond order is more, bond length is lesser. Bond order is directly proportional to stability. Bond order is directly proportional to stability. Okay. Inverse, both are inversely related. Next, keep it molecular orbital configuration. What is the use of Learning molecular orbital configuration. You can predict paramagnetic property. You can predict existence of the molecule. Okay, molecular orbital configuration. Next step. We have two cases. What are the two cases? Less than or equal to 14 electrons, greater than 14 electrons. Case 1, less than or equal to 14 electrons. Sigma 1 is sigma star 1 is sigma 2 is sigma star 2 is pi 2 px is equal to pi 2 py sigma 2 pz. Pi star 2 px equal to pi star 2 py sigma star 2 pz. Sigma star 2 pz. This molecular orbital configuration is used when number of electrons are less than or equal to 14. Case 2. Case 2 greater than 14. See, swap these two. Swap these two. The remaining is same. Just swap like this. The remaining is as. Sigma 1 is sigma star 1 is sigma 2 is sigma star 2 is. Now, sigma 2 p is pi 2 px is equal to pi 2 py. Pi star 2 px is equal to pi star 2 py. Sigma star 2 pz. This is for above 14 electrons. Okay. Let us see how to predict the paramagnetic property, diamagnetic property, existence of the molecule. Before that, write bond order here. Bond order is equal to, actually we completed bond order, but actual procedure. Number of electrons in the bonding molecular orbital minus number of electrons in anti-bonding molecular orbital by 2. Here NB is equal to number of electrons in, NB is equal to number of electrons in BMO, bonding molecular orbital. Na stands for number of electrons in ABMO, anti-bonding molecular orbital. Actually, this is original procedure, but by using that 14 electron, you can write directly, okay, instead of writing all the configuration, but not applicable in all the cases. Clear? When you get electrons less than 10, then how that 14 electron table won't work. Correct only, na? That is having limited access, limited application only. When I give you some other different example, for example, H2 minus, how can you find bond order? By using this one, H2 minus, Be2. How can we find? By using this one out. Very, very important. Akshara, be there. Akshara. Santoshni, are you there? When bond order is equal to 0, then molecule do not exist. When bond order is equal to 0, molecule do not exist. Finding magnetic property. Finding magnetic property and exist. Let us take one example. N2. N2. N2 is paramagnetic or diamagnetic. And how many electrons are present in bonding molecular orbital? Sometimes you'll get question like this also. How many electrons are present in bonding molecular orbital? How many electrons are present in anti-bonding molecular orbital? Then what we have to do? We have to write overall configuration, molecular orbital configuration. First tell me number of electrons. 7 plus 7, nitrogen atomic number is 7. 7 plus 7, 14. 14 electrons are there. So what we use? Case 1 or case 2? We use case 1. So case 1, first write configuration sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Phi 2px is equal to phi 2py, sigma 2pz. Phi star 2px is equal to